We built a core computational cluster, and this is one of the many workloads that can run on the cluster.
It has 1 GPU node and 4 compute nodes, all of which have 2 AMD EPYCs with 64 cores each.
And then they're connected via networking, right? And they maintain quorum between the 5 nodes. Very high throughput for communication during model generation or during AI.
Yeah, absolutely. The networking is certainly an important layer of any HPC cluster. One advantage of having a fast networking is it allows workloads that aren't strictly distributed to kind of still run effectively.
What this lets us do is test software that would run on clients' clusters, as well as different configurations for software and provisioning that might work for our customers. This is Scrappy. HPC applications have different requirements. NVIDIA has an entire tool. This lets us test software using that, as well as practice provisioning, programming for HPC, and just setting up various applications.
Show us how clustering works in a proposed customer environment and test out how much it can actually take, and then translate that to the customer's uses and see what their exact product could handle.
And on a test server, it's really no big deal. If we run into an issue with the VM, we can rebuild it from scratch, try it again, find what VMs, what OSs have the best performance, and various other tasks. The hypervisor allows us to basically spin up any operating system, any hardware configuration that we would like.
If you have a very specific and specialized software stack, it is highly beneficial to have us install your hardware and set up the software stack in such a way that it will work, as soon as the cluster's powered on. Because there's a lot that goes into the configuration of the hardware when it comes to high performance computing. Slurm, Werewolf need a very specific architecture, or you'll have issues. We know the hardware and we know the software. So this is Scrappy, the local LLM running on our system. So this would be a good example of how local AI would be useful for scientific research. This program simulates weather patterns using images and video from actual satellites, and then it uses the GPU to predict how it thinks the weather patterns are going to form and flow. So I'm going to give it 24 history hours, and I'll give it 48 forecast hours. Actually predict weather, right? Cloud vectors, moisture, and bubbles of air, stuff very useful for predicting storms.
Climate change, the study of it involves aggregating a large amount of data across many different inputs and then figuring out how that fits into the bigger picture, which AI is very good at.
The team at Aspen Systems fine-tunes exactly what you need, delivering custom solutions for any scenario. Contact us today and we can get started towards the path of HPC and AI system perfection.